Problem 63 shows an arrangement of capacitors in series here across a 30-volt power supply. And the problem wants to know, when the system's all hooked up, what charge does each capacitor end up getting and what voltage would be across each capacitor. So a 12, a 4, and a 6 microfarad capacitor connected in series like this. So what you do in a problem like this is you notice that they're all in series like this. So let's just break the circuit down into one equivalent capacitance, something like this and something like this. This will still be 30 volts here. And if I combine these in series, according to the series combination equation here, I'll get that this ends up being a 2 microfarad capacitor, a single 2 microfarad capacitor. So the 12, the 4, and the 6 in series all combine to be 2 microfarad capacitor in sum total. Now, the reason for doing this is because when I get a very simple circuit like this, it's very easy, say, to calculate what the charge on the capacitor, this capacitor, must be now. It's just the definition of capacitance. Q is equal to CV, which is 2 microfarads times the 30 volts now, something like that. And so the charge I'll get will be about 60 microcoulombs. So when this capacitor is all charged up here by the 30 volts, a 2 microfarad capacitor will acquire 60 microcoulombs of charge on it. What do I do with 60 microcoulombs? Well, remember the 2 microfarad capacitor came from all of these in series here. So if this one capacitor here, which is the equivalent capacitor, gets 60 microcoulombs, then lo and behold, that must be the amount of charge that goes on to this series of capacitors right here. And because they are all in series, the definition of series is that the charge on the 12, the 4, and the 6 will all be the same. In fact, it will be also 60 microcoulombs, this number right here. If 60 microcoulombs flows onto the 2 microfarad capacitor, then the 60 microcoulombs is also the total amount drawn by these capacitors, but since they're all the same, they're all in series, they must all have the same charge on them. So that means that 12 microfarad capacitor, the charge on the 12 microfarad capacitor up here is 60 microcoulombs. The charge on the 4 microfarad capacitor is 60 microcoulombs, and the charge on the 6 microfarad capacitor is like 60 microcoulombs. They all get 60 microcoulombs on them. Now, that's part of the answer. They all get 60 microcoulombs on them. That's the charge that each one of them gets. Now, if you wanted to know the voltage across each now, you can once again apply the capacitance equation here, that Q is equal to CV, or alternatively, V is equal to Q over C. So if you want to know the voltage on either capacitor, all you have to do is divide the charge that each one gets by its capacitance here. So I'll just sort of do that up here in the margin. This capacitor, the 12, the voltage across the 12 microfarad capacitor here will be the 60 microcoulombs divided by the 12 microfarads. So the voltage on the 12 microfarad capacitor will be 5 volts, something like that. And you can do a similar operation for the other ones right here. The voltage across the 4 microfarad capacitor will be the 60 microcoulombs divided by the 4 microfarads. So the voltage across the 4 microfarad capacitor will be 15 volts. And lastly, you can do the same one for the 6 microfarad capacitor. The voltage on the 6 microfarad capacitor is the 60 microcoulomb charge it acquired divided by 6 microfarads. So the voltage across the 6 microfarad capacitor is 10 volts. So 10 volts, 15 volts, and 5 volts. Those are the volts here. 5 volts here, 15 volts here, 10 volts here. Notice they add to be 30, as it must. And the charge on the 12, the 4, and the 6 are all the same, 60 microcoulombs.